Hello, my name is Luminica Moruz and I'm part of Lucas Schell's lab at Science for Life Laboratory in Stockholm, Sweden. What I'm going to talk to you about in this tutorial is how you can use our new software tool called GradientOptimizer to calculate MS1-optimized gradients. And MS1-optimized gradients are a type of nonlinear gradients that we proposed in a paper recently published in Analytical Chemistry. I strongly encourage you to read this article before trying out Gradient Optimizer and before watching this tutorial. Here I will only explain the main ideas behind using nonlinear gradients, while in this article you'll find out more information about the use of such gradients and the advantages they have. But first, before describing Gradient Optimizer, I would like to very briefly give an intuition as what are nonlinear gradients and what are they useful for. As you know, when we separate peptides on a reverse phase liquid chromatography column, we use this kind of linear gradient. So that means that if we plot on the horizontal axis the time and on the vertical axis the percentage of organic solvent that we add at a certain time point, we will get this kind of line. The problem with using this kind of linear gradient is that it gives an unequal distribution of the peptides over the run. So this is the distribution that we obtain for one of our runs. Here on the horizontal axis we have the observed retention time, and on the vertical axis the number of peptides. As you can see, there are quite few peptides eluting in the beginning of the run and many more in the middle of the run. And following this observation, we wonder whether we can design a nonlinear gradient function such that we would obtain an uniform distribution of the peptides over the run. So the same number of peptides will elute in a time unit. A few words about MS1-optimized gradient. This gradient aims at giving a uniform distribution for the abundant MS1 peaks. And this is the workflow. What is illustrated here is the workflow to calculate such a gradient. We start with the shotgun proteomics run, where we use the linear gradient. So a typical shotgun proteomics run, we extract all the MS1 ions or MS1 features that are above a certain intensity threshold, and we look at the distribution of these features across the retention time. We most probably will get this kind of skewed distribution with less peptides in the beginning and more peptides observed in the end of the or in the middle of the run. Now from this distribution we can calculate what would be the optimal distribution that we would like to have, and finally from here we can calculate the gradient function that would give us this distribution. And this is the MS1 optimized gradient, is the nonlinear function that would give us an equal distribution of the abundant MS1 features across the run. Now I will describe step by step how you can calculate such a gradient using our Gradient Optimizer tool. First of all, you have to make sure you have Java installed on your computer. This is a MacBook, so one simple way of checking if Java is installed is to open a terminal window and just type the command java -version. And then a message will appear on the screen like similar to what you see here, Java version 1.7. If Java is not installed, then some error message will appear. If you use another operating system like Linux, it's going to be similar. You can check the Java installation in a similar fashion. If you're using Windows, you can just Google checking Java installation on Windows and it's going to be straightforward to do that. If you don't have Java installed, just it is freely available. You can just install it from the internet. Now once you check that you have Java, you have to prepare an MZML file from a shotgun proteomics run with a typical linear gradient. That is basically just any run where you use the linear gradient from your lab. There are two things that I would like to point out when it comes to the conversion of the data to MZML. First is that you should use a 64-bit precision when converting the data. This is important because we use a library that assumes that the data has 64-bit precision. And the second observation, please make sure that you have centroided data in the MZML file. This is mostly because if you don't have centroided data, these files can get really big, 15, 20 gigabytes sometimes, and it will require a lot of memory. So the application will easily run out of memory unless you have a very powerful computer. This is just an example of how you can convert your data. For the purpose of this tutorial, I converted my data using the MS-convert utility from the Proteo wizard. And I use this command, so MS-convert --64 filter and specifying peak picking, and then I gave my raw data file. So this is one way you can convert your data from the raw format to the MZML. You can use any other software as long as you keep in mind this two observation, the 64-bit precision, and please use centroided data. Once you have your MZML file ready, the next step is to download the GradientOptimizer tool from this link given here. So I'm just going to copy this link into my browser. And then this page will be loaded. The only thing we need to do is just click this green button here where it says GradientOptimizer.jar and save this file in a convenient place. For example, I'm going to save it on desktop. Once this file was downloaded, it is sufficient to just double click it, and then the main window of the application will open. And this is how this main window looks like. In the upper part of the window, we are asked to choose the type of nonlinear gradient that we want to calculate. As I mentioned in the beginning, in this tutorial, we're going to look at MS1-optimized gradients. After we choose this type of gradient, we have to give an MZML file that was run using a linear gradient. And for the sake of this tutorial, I prepared such a file. This is nothing else than a 2 hours run based on a typical linear gradient. Also, we need to give an intensity threshold. So only MS1 peaks above this intensity will be used to calculate the optimized gradient. All the MS1 peaks below the intensity will be ignored. Here I'm going to use 50,000. You can use any value that makes sense for your data set. And you can also experiment a bit with this value. It may be, you can use, for example, the minimum intensity that you use for a certain peak to be selected for fragmentation, or any other value you think it makes sense. We don't need to fill anything else here. We can go to the next panel where we ask to give information about the linear gradient that was used to generate this MZML file. In this case, it was a 2 hours gradient starting at 10 minutes, going to 130 minutes, and starting at 2% B and going to 40% B. We also need to set a parameter that is called lag time, which gives us the difference between the times in which we instruct the LC instrument and the times that are given in the raw file. For this dataset, this value was -6.9. It can both be a negative or a positive value depending on your settings and your instruments. And I encourage you once more to read this article to learn more about what this value means and how you can estimate it for your own system. In the lower part of this window, we can give information about the formatting of our nonlinear gradient. We can give the time step. How often should this gradient be sampled? For example, 1.0 means that every minute we will get the corresponding percentage B. how many decimals we have for the percentage b. We can, for example, say we want 2 decimals instead of 1. And we can also mention different characters that we want to have in the formatting. Now once we set all these parameters, we just press this button to calculate gradient. And depending on how large is this MZML file, we may be prepared to wait a bit. Because the application needs to load the MZML file, is going to find all the MS1 spectra, extract all peaks above the given intensity, and then calculate the gradient that will optimize the distribution of these peaks across the run. So be prepared to wait a few minutes. As soon as the calculation were completed, then this kind of result window will pop up. And in the left side of the window, you will see the nonlinear gradient calculated by the program. So it's a list of times and corresponding percentage b. While on the right side, you will have a graphical representation of this gradient. So you can immediately get an idea of how different is this gradient from a linear one. You can also experiment a bit with parameters. So if you can keep both windows open, and then you can change the values in this lower side. For example, we would like to sample our gradient at every 2 minutes instead of 1. We'd like to have only 1 decimal for the percentage b. We change this value, we press calculate gradient, and instantly we can see the results in this window. We can also, for example, say that we would like to have the formatting of the nonlinear gradient changed. Again, we change this value here, and we should immediately see the result in this window. So you can experiment with all sorts of parameters here. What's interesting to know is that as long as you experiment with parameters in this part of the window, then the results will be visible instantly. If, on the other hand, you start modifying, for example, the intensity threshold, then the MZML file will be reprocessed, so it's going to take a bit longer until you're going to get the results. But in any case, the results window is always updated to reflect your changes. After you decided what are the best parameter values for you, you can easily save the gradient by pressing this button, Save Gradient. Let's say we want to save it on the desktop, and we call it MS1 gradient .text. We press the Save button, and then if we go on the desktop, we will see this file that was created called MS1 gradient, which will include this gradient that we just calculated. So I can zoom in a bit, and this basically exactly what we have in this window, which is saved to your to a file, or you can just copy to the clipboard and paste it into your ELSE system. And this is all. So just to summarize, you download the application, you double click it, you get the main window, you choose MS1-optimized gradient, you give your MZML file and the intensity threshold, information about the linear gradient and about the formatting of the output, and then you just press the calculate gradient button and you obtain an MS1-optimized gradient. I hope this tutorial was useful, and I'm looking forward to hearing about your experience with using our GradientOptimizer tool. If you're interested in trying other types of gradient, like the in silico optimized gradient or the gradient based on a custom distribution, please follow our tutorials where we explain how such gradients can be calculated. Thank you for watching this video.